If a plus b whole divided by a is equal to b divided by a plus b, then prove that both a and b cannot be real. First, note that both a and b cannot be 0, because then the given equation becomes 0 by 0 on both sides, and that is absurd. Also note that a and b cannot be equal, because then the left-hand side of the given equation becomes 2 and the right-hand side of the equation becomes half, and this is also absurd. With these factors in mind, we will solve this problem by two methods. Method 1. By cross multiplication of the given equation, we get a plus b whole squared is equal to ab. Let us call it equation 1. Then, taking the square root of both sides, a plus b is equal to square root of ab. Let us call it equation 2. We know that a plus b whole divided by 2 is the arithmetic mean of a and b, and square root of ab is the geometric mean of a and b. We also know that arithmetic mean of two numbers is always greater than or equal to their geometric mean. If you do not know this, see one of my earlier videos for proof. Therefore, a plus b whole divided by 2 is greater than or equal to square root of ab. Then a plus b is greater than or equal to 2 times square root of ab. Note that the equality kicks in only when a is equal to b. But in this case, a cannot be equal to b. We have discussed this earlier. Therefore, a plus b has to be greater than 2 multiplied by square root of ab. But the equation 2 gives a plus b is equal to square root of ab. These two equations contradict each other. Thus, no real numbers a and b can satisfy the given equations. So, both a and b cannot be real numbers. Method 2. From equation 1, a plus b whole squared is equal to ab, or a squared plus 2ab plus b square is equal to ab. We can write this in another way, that is a square minus 2ab plus b square plus 4ab is equal to ab. The left hand side is a minus b whole square plus 4ab. Taking 4ab to the right hand side, we get a minus b whole squared is equal to minus 3ab. But since from equation 1 ab is equal to a plus b whole square, 3ab or minus 3ab will be equal to minus 3a plus b whole square. So you get a minus b whole squared is equal to minus 3 multiplied by a plus b whole squared. Taking square root of both sides, we get a minus b is equal to square root of minus 3 multiplied by a plus b. If we assume that both a and b are real, then a minus b is a real quantity and a plus b also is a real quantity. So equation 3 then becomes a real quantity, that is a minus b, is equal to an imaginary quantity, that is square root of minus 3 multiplied by a real quantity. And because this square root of 3 is an imaginary quantity, equation 3 will not hold good. Therefore, by reductio ad absurdum, or by reducing our argument to absurdity, our assumption that both a and b are real is false. Therefore, we conclude that both a and b can't be real.